First, let us review what is linear regression. So as we have discussed in Math 1 with Sir Eugene Beringal, linear regression is a statistical analysis used to predict the value of a variable based on the value of another variable. So the variable that we want to predict is called the dependent variable, or also called as the criterion variable, which is represented by y. And also, the variable that we are using to predict the other variable's value, the value of y, is called the independent variable, or also called as the predictor variable represented by x. So, when we're talking about linear regression, this consists of finding the best fitting line through the points on a scatter plot. So first, we need to gather data, and then we're gonna plot it on a scatter plot. So our group decided to gather data relating to the age and the average amount of time spent by a teenager on using a gadget. So when we were saying about gadget, it considers everything that is using electricity, like smartphone, laptops, and tablets. So here we have gathered the data where x is the age and y is the number of hours spent. So here we have a sample of n equals 19, and with the use of Excel, we are able to calculate conveniently the value of xy, the value of x squared, and the value of y squared. So here we have the summation of xy, which we got conveniently by using the formula function on Excel, similar to the others. Summation of x squared, summation of y squared, and even the average of x and y. We also computed it conveniently with the use of Excel. So since we're talking about the best fitting line, or also called the line of best fit, or as we have commonly known in our Math 1, the Lslr line, or the least square linear regression line. So since we're talking about line, we have this equation. So y equals ax plus b. Here we have two coefficients, a and coefficients b. So I think some of us may be familiar of this equation, since this is also very similar to the general equation of a line, which is y equals mx plus b. Here we have m as the slope. We also have b, which is the y-intercept. So basically, y equals ax plus b is equivalent of y mx plus b. So this is the least square linear regression equation. So for us to find the equation on a linear regression line, we need to calculate these two coefficients. We need to find the value of a and the value of b. And for us to get that, we are also given the formulas on how we could compute these two values. So here we have b equals the mean of y, or the average of y, subtracted by a. So referring to a above, multiplied by the average of x. So since we haven't computed yet the value of a, we need to first compute the value of A. So given by the next equation. So we can get the value of A by using the formula n multiplied by the summation of xy subtracted by the product of the summation of x and the summation of y, all over n multiplied by the summation of x squared, then subtract by the square of the summation of x. So here we also have the equation for r. So r is the linear regression coefficient, which we will use later on for our conclusion. So let us first solve the value of A. So before we proceed with our computation, we first need to write down all that it is given, or all that we have known. So we know that we have a sample of 19. So we have n equals 19. And then also from the Excel spreadsheet, we are able to find out the summation of x, the summation of y, the summation of xy, summation of x squared, and the summation of y squared. So from this spreadsheet, we know that we have computed that the summation of x is 310, and the summation of y is 160. The summation of xy is 2711. And the summation of x squared is 5148, and summation of y squared is equal to 1914. So now that we have all these values written down, we can then easily solve the value of the coefficient A. So let's go back to our equation. So we simply need to substitute this value on the equation. So first we have n, so 19 times the summation of xy, we have 2711, minus the product of the summation of x and the summation of y. So we have 310 and 160. And then on the denominator, we have 19. Then the summation of x squared is 5148, subtracted by the square of the summation of x. So we need to be careful in this one, because it says that the summation of x, it says here that the square of the summation of x. So we have to copy the summation of x, 310, and then square it all up. So now that we have substituted all the necessary values, we use the calculator, and according to the calculator, this equation results to 1.115070. So I just copied up to 6 decimal places on the calculator, and then we can approximate this into A equals 1.1151. So we got the value of the coefficient A. So the next thing we need to do is we will solve for the coefficient b. So the coefficient b is, oh, I forgot to write down in the given. That we also need to put the average of x and y. So the average of x is 16.3158 and the average of y values is 8.4211. So now we can solve for the coefficient b. So the average of y, which is 8.4211, subtracted by the product of a, since we know that the value of a is equal to 1.1151, multiplied by the value of our average x, which is 16.3158. So using the calculator, the value of this one is negative 9.773. So we have the value of b. And then the next thing we need to do is we simply plug in this value, the value of a and b, on our equation. So our equation is y equals 1.1151 minus, so this one, the value of v is actually negative 9.7722. So this is wrong. We have this value negative 9.722. I apologize for that, rounding up. So we substitute the value of a, which is 1.1151x. So we simply need to copy up to 4 decimal places. And then the value of b, which is positive negative 9. Negative 9.7722. So since we have positive and then negative, so our final Lslr equation is 1.1151x minus 9.7722. Okay, so this is the equation of the best fitting line, or the Lslr line. So next, we proceed with getting the linear regression coefficient r. So the linear regression coefficient line, so we know that the equation for that is this one. R equals the product of the sample multiplied by the summation of xy subtracted by the product of the summation of x and the summation of y, all over the square root of n multiplied by the summation of x squared minus the square of the summation of x multiplied by the square root of n times the summation of y squared minus the square of the summation of y. So we simply need to substitute the value of what is given on the equation. So we have n, the summation of x, summation of y, summation of x squared, summation of y squared. So plug it all up in the equation. And then we have 19 multiplied by 2711 subtracted by the product of the summation of x and the summation of y, which is 310 times 160 all over the square root of 19 times the summation of x squared 5148 minus the square of the summation of x, so 310 squared multiplied by square root of 19 n multiplied by the summation of y squared, which is 1914 minus the square of the summation of y, so 160 squared. And putting this all in the calculator, we input these values, we are able to find that the value of r is equal to 0.437835. So our value of r falls in the range of r is 0.50. So here we have the linear regression coefficient r, which is equal to 0.437835.